try decision trees, which are another one very interesting. Decision trees are machine learning that is so simple, it seems like it's not even machine learning. So again, we'll make a data set. And this is going to load a famous data set of iris flowers, which has been used for machine learning for a really long time. Somebody made a set of flowers, not very many, 150, of 3 different types, and sorted them into 3 categories, and then measured different lengths of the petals and stuff on the flowers. And so the result of that is you can do some degree of separation of these things. So here's classifying it with a decision tree. And all right, there we go. All right, so this is the decision tree, and it goes like this. There's petal length, there's petal width, and that's all we're going to use is those 2 parameters. And so petal length here, there are 3 categories we're sorting them into. Setosa, versicolor, and virginica. Those are the 3 types of irises. And so if the petal length is less than 2.45, you start with 150 samples here. And the ones less than 2.45 or less than equal are over here. And this is the distribution. Your original data set is 50 of each category. And there's a thing called the Gini impurity here, which is like a measure of entropy. That is how impure the data is here. A high number means you haven't really separated the data very well. So after the first one decision, based on this one parameter, all 50 of the setosas are over here with none of the others. So the job is completely done perfectly. That one measurement is enough to totally isolate these, so Gini impurity is now 0. So this part is done. So that's handy. That was like the first support vector machine I showed you. There's a complete gap between setosa and the others, and you can just separate it with one if statement. Then this one here now has none of this first category, but it has 50 of each of the other 2 categories, so it's still pretty impure. The impurity is 0.5. So now you go to petal width and divide by that minus 1.75. That gets you down to 49 of 1 with 5 extras, and here you get 45 of 1 with 1 extra. So both of these are not perfectly pure, but they're pretty pure. And so the Gini coefficient has gone down to 0.1 or 0.04. So with 2 if statements, that's why the support vector machine hardly seems like machine learning. It's just 2 if statements. If one parameter is one way, go here. 2 if statements is all it is. That's all a decision tree is. It's just a series of binary if statements. You wouldn't think that would be powerful enough to get anything done. Just like the support vector machine sounds so simple, it couldn't be powerful enough. This turns out to be one of the most powerful models.
Yeah, no, if statements combined with for loops, while loops, just loops in general, is one of the most powerful things in coding as far as I've done so many coding exercises in high school where 90% of them were solved basically by spamming if statements.
Yeah.
If I needed to get a certain process done,
yeah,
I'd chain it through different if statements in a loop.
Yep, you're absolutely right.
It would always work.
Yeah, you can get a lot done this way.
Yeah, the only issue that ever came up would be doubles of getting the same number, like if you need to find multiples of 3 and 5. So then you can just use an if statement to see if the number is a multiple of both and just go through there and count it as 1. So I have that as the top if statement, else if it's for the first one, else if it's for the second. It's so simple.
Yeah, in principle, it's Turing complete, so you can't get anything done. But the fact is here, you're just going to use a relatively small number of them, and they're surprisingly successful. So that's this one. That gets me, now you can control the depth of it. So here we can make a chart showing the predictions, understand better what extent it works. We're going to make a chart of the 2 parameters we're using of the petals, and then color code them. So here's the one category here. That's why one if is enough to completely find all 50 of these. These ones overlap, and the if statement on one parameter can only be a horizontal line or a vertical line. You can't, so this is the best horizontal line to separate them, and as you can see, it's not perfect. There's a blue up here, and there's some greens down here, but that's what we got. That's 2 layers of if. Now, it would have been better, but in order to do that with the support vector machine, you'd have to add another parameter that's like x1 plus x2 or something. And you could do that. Okay, but so now, if you just change the depth to 3, then it will be allowed it to only have 2. Now you let it have 3. It'll split these again and make them better. And again, the genie goes down, and enough if statements, it can eventually separate them all into individual boxes in principle. So that's the point.
I think the most if statements I've ever had in one coding session was when I made a massive choose your adventure path for one of my assignments and went overboard. So it had like 40 if statements.
Yep.
I made an entire, like if I could print it as a book, it would be about this thick.
Yeah, and you know the classic game 20 questions. 20 if statements are enough to find anything. It's just separate because it gives you 1 million choices.
Yeah, that's also kind of how Akinator works, except he goes like 40 questions at most, and
Yeah.
he gives so.
Well, 40 questions is enough to get a millionth of a millionth. So it can pretty much answer almost any.
Past a trillion.
Yeah. Anyway, so all right. So now let's try another one. You can fit curves with decision trees, which is another thing that sounds too stupid to be true. So let's have a curve, and this is going to be the one we used before: x times cosine of x plus noise. So we're going to have a wavy curve here, and we're going to try to fit that with the decision tree. So if you do, here's regression with the decision tree. There we go. All right. And so now, here's the steps showing it in this form. Well, it's not obvious what's going on here, but what is kind of obvious is there's only 4 possible outcomes. That doesn't sound good. So if we're going to graph it, we're going to see something terrible, as you would imagine. That's the fit. What can it do with only 2 layers of if statements? It can't do a very good job, of course. But that's because you lowered it to only 2 layers. So what you can do...
I can't even tell what it's trying to separate between the two.
Well, it's trying to fit the curve. So all these ones, it puts them here, and these ones, it puts them there, and these ones, it puts them there. So it's these 4 horizontal regions, which sort of follow the shape as well as you can, with only 4 flat zones. But it clearly missed most of the curve. So,
What I'm trying to
Yeah.
figure out is if it's trying to split them evenly top and bottom.
No, it's just taking an if statement here. And you see, if this parameter is like above minus 8.5, then put it here. If it's below, put it there. That's all these if statements on the x to predict the y. And but you can increase the depth. If you go to depth 6, now it can have 2 to the 6 heights. This is actually quite related to analog to digital. If you have an analog signal like radio, you can digitize it with certain steps to turn it into like digital music. And if you have enough steps, it's pretty accurate. Here it's better. And here you can actually make unlimited depth. And this is an issue. If you let it go as far as it wants to, then it will perfectly spike every data point, including following all the noise.
Are you sure
Yeah.
that's not just a broken graphing calculator?
No, but the point is, this is what I mentioned before. This is overtraining. Now, you're going to get a really low error, but you're not actually training the trend of the data. You're fitting the noise. And this is what happens with large language models. Large language models were supposed to take all the text on the internet and learn the general structure of English, like they'd studied a grammar book. But they overtrained them, so when authors went to ChatGPT and they would put in like the first couple paragraphs of like Harry Potter, it would just spit out many pages of Harry Potter exactly the way it was. So they had overtrained. They had just memorized the input data. And that's why they got sued by the New York Times and everybody saying, you're stealing our content. And they said, no, we're just reading your content the way a human would to get the general meaning. And they said, well, no, you're not. You appear to be just totally wholesale duplicating the content. And that's going to be their argument in court, and that's going through the battle, whether what they're doing is fair use or not. And so here you see the result of overtraining. But the decision trees turn out to be the most powerful model. And one thing that's amazing about these, it's not in this project, is the most powerful machine learning model, one of the most common and most powerful, is a forest. And what you do is you make decision trees, but you don't even optimize them at all. You randomly choose the thresholds and randomly choose the parameters. Just randomly split it, and then you make like 500 of them, and then you combine all the outputs of those 500 in the best way. And that turns out to be quite easy and powerful.
There's a YouTuber I watch a lot, and I still watch him. He just doesn't upload that often. Called Code Bullet. And some of his videos are using that learning AI to get the he sets up. He basically lets the AI control characters in a simulation, and then they just start whenever we tried to get them to walk, they'd always learn to walk backwards or to fall over and crawl.
Yeah,
It would be visualized as it'd start off with 4 nodes or 4 main inputs, and then he'd give itself access to add more inputs as it sees fit.
oh, that's a very good, yeah,
By the end,
yeah.
when he first started, he actually had 200 or so inputs and about 50 outputs of what it could do, and it was just a huge mess. It had like 15 layers, and
Yes.
and what it was doing was walking backwards.
Yeah, and this is a real important issue. We're trying to make robots that learn and follow AI. Should you figure out the right number of parameters? Yeah, anyway, so that's the beginning of decision trees, an important category of AIs. So let me stop this recording.